What is the first derivative test? And how does it work? The first derivative test is a way to determine the local maxima and local minima of a function. As you may recall, the local max of a function is where it changes direction from increasing to decreasing, and a local minimum of a function is where it changes direction from decreasing to increasing. So, let's say we have this function. How do we find the local maxima and minima of this function? Well, using the first derivative test, we need to first take the first derivative. We can do this pretty easily. We use the power rule. And let's move this up here to give us some room. And we factor out the 10x squared. And now we need to find the zeros. Not the Zorros, but the zeros. What do I mean? Well, every local maximum or local minimum of the original function will occur at a point where the first derivative of the function equals 0. Why is that? Well, wherever the original function changes direction, the first derivative of the function is going to have to change from positive to negative or negative to positive. So it's going to have to equal 0. So what we need to do now is factor the original function, which I've just done. And this allows me to tell exactly when the first derivative equals 0. It will only equal 0 whenever the factors themselves, one of the factors themselves, equals 0. So this allows me to see that it will only equal 0 when x equals 0, x equals negative 1, or x equals 3. And this allows me then to plot these points on a graph and pick some random values in between these critical points that will allow me, by plugging these values into the first derivative, to tell whether the first derivative is positive or negative on all sides of these critical points. Now, all I care about is whether the function is positive or negative on either side of the critical points. I don't care about the exact values. So I'm going to calculate that. And this allows me to guess at the shape of the first derivative function. I can tell exactly when it crosses the x-axis. And the points where it crosses the x-axis are important because these are the points where the original function is going to change direction. So I see here that the first derivative is positive up to negative 1, negative from negative 1 to 3, and positive again after 3. It'll probably look something like this. And this information allows me to guess that the original function has a local maximum at negative 1 and a local minimum at 3, since these are the places where the first derivative of that function changes from positive to negative or negative to positive. So how does this work? Well, here are the steps we use in the first derivative test. First, we find the first derivative. Then we find the zeros of the first derivative. Then we calculate the value of the first derivative for values on all sides of the critical points. And we use this information to determine where the original function changes direction. Well, that's the first derivative test, and that's how the first derivative test works. And here's Zorro again. Okay.